Okay, we continue back to another module. This is from your module 36. Let's read some of the slide also given in your blackboard in the last part. Okay, module 26, 7, and 28. But this is the one which very important for you before you start your lab test too. Understand about the alert and also the tools that use in your lab. So there are two main topics or subtopic about the source of alert to identify the threat, where we got the alert from and why the alert are generated, and then how to actually evaluate the alert, how the alert will be classified into different uh, so that you can manage it properly based on the okay. Now we have a security onion, the suite or the tools or solution which actually open source, one of the network security monitoring tools run on Ubuntu Linux distribution. That's why your uh, server ops virtual machine actually on Linux, Ubuntu Linux, they are customized and run with integrated or embedded tools inside. So the security onion. This security onion actually provide you three core functions of the cybersecurity analyst, such as full packet capture and data type, network-based and host-based system, and analyst tools. So network-based like Snort, host-based like there already integrate together and package in the um, manageable environment to ease uh, the security analyst and workload. That is network security monitoring tools. Onion. Onion can be installed and as a standalone solution or a sensor and a server platform, depending on your already. Some component of security onion are owned and maintained by corporation such as Cisco or and Riverbend Technology, but are made available as open source. Some of it are managed by open source community. So Cisco contribute and manage, and they also make it by available as open source. So this is the contribution for the community. So now we see how to how this detection tool or detection tools like this onion collect the data, collect the alert data. You can see here there are three major level. Okay, from the data itself, normally data we can call it as raw data, which came from pick file contain data, in the contents of the data, the transaction data or session data, log from the host, and alert data from the other tools, system log, and metadata. So this data, if we get it without the proper mechanism to analyze and visualize it, very difficult to get the correct information that we want actually. So we need the tools can process the data, can analyze the data, aggregate, and make it visible, make it visualized, which can be easy for the analyst to work on it, right? And the detection mechanism, the tools here, see here, CAPME, SNOT, one of it, ZIG or PRO, so IDS, right? Wazoo, Surikata, and OSEC. Surikata and OSEC is more on the host level because we need both network level and host level to work together in order to get whole or complete analysis of the particular data. If only network level, but the data for application level or the operating system level will be not successfully analyzed and component work together. Lastly, they integrate together with the analysis tool which combine together the SQL Wireshark and Kibana as their analysis. So if, for example, I have this node, but I don't have others component, which difficult for me to integrate together manually. So this is very good tools, solution, or the suite for for you as a system or security analyst. So this is table of the detection tools of the security onion. For example, CATME. What is the uh, what CATME is application that allow viewing of PCAP transcript rendered with the TCP or ZIC tool. This is more application, okay, web application part. But for SNOT, this is network inclusion detection system and IDS, which important source of alert data is indexed in the skill analysis tool. This is the then they send their result to skill analysis. ZIC or formerly known BRO, also considered one of NIDS that use more of behavior based approach. Here, when it's not combined together with ZIC Pro, they will give us better type of detection because it's not more on signature base, more on the rule base, uh, pattern base, but for ZIC more on the behavior based detection. So if let's say a new type of attack did not yet analyze and did not yet come with the pattern or signature, then ZIC can help to include. Other than that, OSAT is a host-based intrusion detection system that integrate into security onion, which OSAT is more on the integrity monitoring tool. Sometimes they call it FIM, file integrity monitoring tools, which this tool will help us to detect any modification uh, done by the attacker or by the malware for the original file system, for example. Because some of the malware they are compromising the system or root privilege or admin privilege, then they modify the system file, which can affect the system to act differently based on what we intended to do, based on their own needs. Okay. Wazoo, this is a full feature solution that provide a broad spectrum of endpoint protection, including host log file analysis, file integrity monitoring, similar with OSAT, vulnerability detection as well, configuration main assessment, and also incident response. It's a big complete host-based solution and endpoint protection. That's mean more on host. Okay, other than that, we see here Suritata, either NIDS, use a signature-based approach to detect any intrusion in the backup level, in the network level. Can be used for inline intrusion prevention. So it can be IPS depending on how we want to make it happen. How to how we use it to protect our network. If you want more on detection, then go for it. If you want more on prevention, but you need to compromise performance, depend on your requirement. And then we're moving to the analysis tool itself. Onion, they integrate various types of data and intuition system into single through these following tools. Will, for example, this analysis tool provide a high-level console for investigating security alert from wide variety of sources. Will serve as a starting point in investigation of security alert. Many data sources are available by pivoting directly from Will to another tools. If we don't have this kind of tools, maybe there are some duplicating data which actually from different type of tools we detect the same attack, but without this skill we will have a lot of attack which actually represent the same attack, the same sources. So we need to aggregate and analyze it to make sure there are no repetition of detection and also reporting. And in Kibana, more in the interactive interface to elastic data. This allows querying of network security monitoring data and provide flexible visualization of data. Possible to pivot from SQL directly into Kibana to see contextual. When the SQL managed to get all the data, then Kibana help in visualizing it in the interactive dashboard so that security analysts can see easily which, for example, which time attack happened, which component, which servers actually down, and so on. Okay. And then Wireshark is a traditional tools that you know already, right? That can capture application, integrate into security onions, so because security onion also require some sort like that to help in collecting the data and capturing the specific type of. It can be opened directly from other tools and display full packet capture relevant to analysis. Sometimes analysts see the end product and end report, but they want to see details of the packet. Then they can use Wireshark and Seek network traffic analyzer that serve as security monitor. It inspect all traffic on the network segment and enable in-depth analysis of that data. So they can pivot so from Sugan into Zig, provide access to very accurate transaction log file content and customize output. You can customize based on what you want. Filter it, customize it. Next, after all the tools can run together, can aggregate all the data collected from various tools, various services, then we need to evaluate the alert. Before we get the alert is generated by this message. Normally, a notification message generated by the tools is network security tool, network monitoring tool, system and security device, your operating system, your servers, uh, your firewalls, right? Firewall also generate alert. So that alert can come in many forms depending on the sources. In your experience, to provide control that integrate alert from multiple sources into time-stamped so that if you are cybersecurity analyst, you will work through the security queue, investigate, classifying, escalating, and retiring alert. Because some of the alert is not required to be in monitoring part or inactive. After that, for example, after you resolve it, you can retire it. No need to store it in any form in order to save. Okay, alert will generally include five tuple information, which normally consists of IP, source port, destination IP, and destination port, as well as the protocol number that they use. This is in network layer, right? To from the source to victim, how the alert generate. Example, alert generation. Later you can see in your lab. And use is will this will application window with queue of alert that are waiting to be investigated at the top of the interface. So normally you can check based on the ST, status of the event. Here, RT, status real time. So the event is color coded by priority based on the category of priority. Very low, low, medium, and high. Like yellow to red. Red means priority. Need to NT is count number of time this event has been detected. So this there are one time, three times, time the same event detected in your network, same IP address and sources. So the recurring attacks based on this source and destination. Okay, and then the sensor, which sensor actually detected? Because some of the infrastructure, they come with multiple sensors. Maybe one in network, another one sensor in your subnet. So all the sensor need to correlate, report in agent reporting. Variable sensor and their identifying number can be found in the status and so on. Some of the IDS, especially for each IDS, host-based intrusion detection system, each of the server or endpoint having their own sensor using the network card. Other than that, we have alert ID. Each alert come with their own ID, uniquely identified for the ID based on the date time, the message, and others. So that's why you need to correlate the time as well, right? Date time here to ensure you know or specific event in specific time. That's why your NET network time protocol are very important to enable in your network environment. And then we have also event message. This is identifying like for the event itself. This is configured in the rules that triggered the alert. Okay, you can see here there are some message regarding the port mounted request and others. I think for the first part, we stop. We will continue back to another part, rules